Good morning to our fellow learners. So I am Metal Draper Vidizo and we will be discussing the number system. So before we proceed to number system, let's find out what is a number. A number is a mathematical value used for counting and measuring objects and performing arithmetic calculations. Numbers have various categories like natural numbers, whole numbers, rational and irrational number, and so on. So a number is very useful to us because other we can even calculate other numbers by using calculator, and we can measure other objects while using numbers. And there are various categories like natural numbers. A example of natural numbers was a 1, 2, and other natural numbers that has a positive number with no signs, no symbols like that, and the whole number. And the very common to use was a natural number and whole number. And the rational and irrational numbers. I think the example of irrational numbers was pi, which has a 3.14, and Euler's number, which has 2.7. That is the example of irrational number. And there are a lot of various categories of a number. And a number system also has a various categories but different properties, which is the binary number system, the decimal number system, the octal number system, and the hexadecimal number system. So the definition of number system. A number system is defined as a system of writing to express numbers. It is the mathematical notation for representing numbers of a given set by using digits or other symbols in a consistent manner. It provides unique representation of every number and represents the arithmetic and algebraic structure of the figure. It also allows us to operate arithmetic operations like addition, subtraction, and division. So, in number system, the very useful is the arithmetic operation because we use this addition, subtraction, and division in a number system. So the value in any digits in a number can be determined by the digit, its position, and the number, the base of the number system. So this is the main purpose for us to know what is the type of number system when we see the digit, the position, and the base of a number system. So there are 4 types of number system. The decimal number system that has base 10, and there has 10 digits, which is 0 to 9. The binary number system that has base 2, which has a 2 digit, is 0 and 1. And the octal number system that has base 8 and has 8 digits, which is 0 to 7. And the hexadecimal number system that has base 16 and has 16 digits, which is 0 to 9 and 8 to F. So this is a chart of a number system. So for us to find out why the decimal has a different number and why is the binary has too much numbers and the octal has just a 8 digits and the hexadecimal has just a number and an alphabet. So let's find out.
Hello everyone and good day. My name is Rosella Snamok from TCM 103A and I'm going to tackle about decimal number system. Decimal number system, which has the base 10, represent any number using 10 digits 0 to 9. Decimal system, also called Hindu-Arabic system or Arabic number system. In mathematics, positional numeral system employing 10 as the base and requiring 10 different numerals. This is what we use in our day-to-day life. Once you reach 9, make the rightmost digit 0 and add 1 to the left, which becomes 10. The decimal number system compares digits from 0 to 9 that are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. The base of radix of the decimal number system is 10 because the total number of digits available in the decimal number system is 10. All the other digits can be expressed with the help of these 10-digit numbers. Decimal number system is the most common and easiest number system in our daily lives. Some of the decimal number system examples are 341 base 10, 56 base 10, 6789 base 10, and 78 base 10. So, how to read decimal numbers? In single digits, from 0 to 9, the numbers are read as it is. But in the case of two digits, the number digit says that it means, but the left digit means 10 times what it says. That is in number 24, 4 is 4, 2 is 20. Altogether forms 24. If 1 is 10 times the digit, left digit 100 times the digit. Simply if we take number 546, it means open parenthesis 5 times 100 close parenthesis plus open parenthesis 4 times 10 close parenthesis plus 8 equals 548 base 10, or open parenthesis 5 times 10 to the power of 2 close parenthesis plus open parenthesis 4 times 10 to the power of 1 close parenthesis plus 8 equals 548 base 10. And that's all. Thank you everyone for listening.
Good day, everyone. I am Macnil Salvania. I will be discussing the binary system. Binary numerical system. Binary number is the most fundamental numbering system in all digital and computer-based systems, and binary number follow the same set of rules as the decimal numbering system. But unlike the decimal system, which uses power of 10, the binary numbering system works on power of 2, giving a binary to decimal. The binary system is applied internally by almost all latest computers and computer-based devices because of its direct implementation in electronic circuits using logic gates. Every digit is referred to as a bit. Then we all know that the main characteristics of a binary numbering system is that each binary digit or bit has a value of either 1 or 0, with each bit having a weight or value double that of its previous bit, starting from the lowest or least significant bit, or LSB, and this is called the sum of weights method. To make it simple, the conversion of binary to any numerical system and back is an important concept to understand, as the binary numbering system forms the basis for all computer and digital systems.
Good day everyone, I'm Sheila Yugasan from Section Villia TCM 103B in the subject IT 113 Fundamentals of Computing. This lecture is about on how to do conversion on number systems. I'll give an example on how to convert decimal to binary numbers. So let's start from decimal to binary, kung papaano natin i-perform ang conversion. Let us convert the given decimal 18 into binary. In decimal, we convert a base 10 number to a base 2 binary number. Dito, magpe-perform tayo ng division para makuha ang quotient at remainder. So, magdi-divide na tayo. Itong 18 na decimal, since ang binary number natin is base 2, i-divide natin siya sa 2. 18 divide 2 is 9, remainder 0. Paano nga ba natin kunin ang remainder na 0? 18 divide 2 is 9. 9 times 2, 18. So, 18 minus 18 is 0. Itong quotient na 9, i-divide uli natin siya sa 2. So, 9 divide 2 is 4, remainder 1. 4 divide 2 is 2, remainder 0. 2 divide 2 is 1, remainder 0. 1 divide 2 is 0, remainder 1. Since 0 na ang quotient natin, mag-stop na tayo sa pag-divide. Para makuha ang equivalent binary number ng ating given decimal, remainder ang kunin natin. So, bilangin natin siya pataas. 1, 0, 0, 1, 0. Ang equivalent binary ng ating decimal is 1, 0, 0, 1, 0. Another example, decimal fraction to binary. Ang given natin ngayon is fractional value ng decimal. So, paano natin ito gagawin? Kapag fraction, nagmumultiply tayo sa 2. Unlike whole number, nagdi-divide tayo sa 2. Pero pag fractional value naman, from decimal to binary, nagmumultiply tayo. Ang given number natin is 0.7125 multiply sa 2. Kasi nga, ang binary number is base 2. Then, ang product is 1.425. So, yung fractional value uli niya na 1.425, iyon ang imumultiply natin. 4.25 multiply sa 2 is 0.85. 0.85 multiply sa 2 is 1.7. 0.7 multiply sa 2 is 1.4. 0.4 multiply sa 2, 0.8. 0.8 multiply sa 2 is 1.6. 0.6 multiply sa 2, 1.2. 0.2 multiply sa 2, 0.4. So, mag-stop na tayo dito kasi kapag i-multiply natin itong 0.4 sa 2, babalik ang kanyang result sa 0.8, kaya stop na. Ang kukunin natin dito is yung whole number na ones and zeros. At dito, pababa naman. So, ang equivalent value na binary natin is 0.10110110 ng ating given na decimal.
Hello everyone, my name is Jason Cuenataro Sumadera. For today's video, I'm going to discuss about the octal numbers. What does octal mean? Octal refers to the base 8 numbering system. It comes from the Latin word for 8. The octal numbering system uses the numerals 0, 1, 2, 3, 4, 5, 6, 7. In computing environments, it is commonly used as a shorter representation of binary numbers by grouping binary digits into trees. Octal is another way to count numbers. While humans normally count in tens and machine count in twos, it is possible to use any number as the basis for counting and calculation. Some Native American tribes have used octal by counting the spaces between fingers. Just like the characters in the 2009 film Avatar used octal because they had 4 fingers on each hand. Using octal is a convenient way to abbreviate binary numbers. Starting from the right, group all binary digits into sets of 3. If the last group on the left does not have 3 digits, then add a 0. Each 3-digit binary group translates into a 1-digit octal number. Start with a binary number. Example, 01011101. Group the binary number into trees. Add a 0 to the left if it's necessary. 001, 0111, 101. Convert each 3-digit group into an octal number. 135. Combine the numerals to form the octal number. 135. And this is your basis of table of number systems. Using an octal number instead of a binary number saves digits. In the early days of computing, octal was often used to shorten 12-bit, 24-bit, or 36-bit words. Hexadecimal is now more commonly used in programming, making number representations even shorter than octal. And that's all for my discussion. Thank you.
Good morning, everyone. I'm Mark Daniel Balingkos from BSTCM 103B. So, in the previous lesson, we've talked about the decimal number system and the binary number system. So, in today's lesson, we will tackle about the hexadecimal number system. So, first, in the first slide of our PowerPoint presentation, we have an illustration which is two hands. So, but the difference is it has 16 fingers, and each finger represents the code or the digit. So, in hexadecimal, we have the 1, 2, 3, 4, 5, 6, 7, 8, 9, and the A, B, C, D, E, and F, and 10. So we have the 16-digit code of the hexadecimal, or in other words, it is called the base 16. So hexadecimal code is commonly used in computing. It usually to create colors in computer. It is also used to create MAC address. So the hexadecimal number system is also known as the base 16. The values of the positions are calculated by taking 16 to some power. Why is the base 16 for hexadecimal numbers? Because we use 16 symbols or the digits 0 through 9 and letters A to F. So the hexadecimal number system. So in binary, we have the 1. In decimal, we have 1. And in hexadecimal, we have 1. So in binary, which is the 1111, in the example, we have the decimal, which is 15. And in the hexadecimal, which is the letter F. So later, I will show you an example about the hexadecimal number system. So I will give you an example. I will show you how to do the hexadecimal number system. So we have an example here, which is the E7. So how can we translate it in a hexadecimal code? So hexadecimal is also known as base 16. So base 16. So we all know that the decimal number system has base 10. Base 10, and the binary also got the base 2, or the 2 digits and 10 digits. So in the hexadecimal number system, we have the base 16 or the 16 digits. So let's start with 0, 1, 2, 3, 4, 5, 6, 7, 8, and A, B, C, D, E, F. But this one represents, the A represents as 11, 12, 13, 14, 15, and 16. I mean 10, 11, 12, 13, 14, 15. So if we solve the E7, translate it into hexadecimal code. First is know the place value. So 7 is the place value of it is ones, and the place value of this is tens. So 7 has the base of 16, so we will put it as 16 to the power of 0. And the E has also the base of 16, but in a tens place. So we will put this one 16 to the power of 1. So if we translate it into a word, it is E16s plus 7 ones. Then we can substitute E as, if we look at the digit of the base 16, so E is 14. Then substitute E. That's 4 sixteens plus 7 ones or 7. And then you can substitute this at 14 times 16. 14 sixteens or 14 times 16 plus 7. So 14 times 16 is, if you multiply it, 14 times 16, 6, 12, 18, 4, 6, 8, 4, 1. So 4, 12, 2. So 14 times 16 is 224 plus 7, so 31. So the equivalent of E7 is 231. 231. For listening, and once again, thank you.
Let us proceed to the example of octal to hexadecimal conversion number system. How to convert octal to hexadecimal numbers? Si octal numbers, ang kaniyang base is 8, and si hexadecimal naman is 16. Ang given number natin is 653.25. Dito, kukunin muna natin ang binary equivalent niya sa bawat value. So, itong 653.25, kukunin natin ang tatlong bit na equivalent niya sa binary. So, ang 3 ay equal sa 011, 5 ay 101, 6 ay 110, 2, 010, 5 is 101. Ang mga ito ay binary pa. Para ma-convert natin siya to hexadecimal, i-group natin ang nakuha nating binary numbers into 4 bits para makuha natin ang equivalent hexadecimal. Sa whole number na part, we proceed to the left side. So, 1101 is 11. 11 is equal to B. The other group is 0101 is 10. 10 equal to A. Then, 1 is isa lang siya. So, magdagdag tayo ng tatlong 0 para maging 4. So, 100, this equals to 1. And sa fractional part naman, we proceed to the right side. So, mag-group ulit tayo ng 4. So, 0101 is 5. Then, the other group is 01. So, dalawa lang sila. Magdagdag tayo ng dalawang 0 para maging 4. So, 0100 is 4. Ang result ay 1AB.54.
Why do we need to do conversion? One of the most important applications of the number system is in the computer technology. Generally, a computer uses the binary number system, but humans will also use the hexadecimal number system, as it's easier to think about and understand. For this reason, the number system conversion is required. Every day we use base 10, 24, 60, etc., like that. The first 3 for time, and the last because we have 10 fingers. It suits computer to use binary and computing specialists to use the power of 2. Weeks, days, months, years, mix bases up. Base are useful, so conversion is needed.